Hi, I'm Emma.
And I am Xavier, and welcome to Season 2 of Curious Conversations, a podcast for kids by kids.
Season 1 was so much fun, and we learned a lot about podcasting, and we learned so much from our guests, too. We are so excited to continue interviewing people from all walks of life and hear their stories to learn about their passions.
Of course, we are still curious, and we're really excited where Season 2 takes us. And let's get started! On today's episode, we welcome Sean Raymond, an astronomer who studies the formation and evolution of planetary systems, and he's also a published poet.
Xavier, I think this is going to be a very interesting conversation. Before Christmas, we did a space unit at school, so I have lots of questions for Sean.
I agree. We only had a little bit of time to look into the stuff that he studies, so I can't wait to learn more about space today. Emma, can you tell us a bit more about Sean?
Sure, Xavier. Sean is an American astronomer living in Bordeaux, France. He studies all kinds of things about space, like how the solar system is formed, where Earth's water came from, and whether moons can have their own moons. Sean has also published a book of astronomy poems that explains complex science topics in a way so kids and adults who aren't astronomers can understand it. So, welcome to the podcast. My name's Emma.
Well, hi, I'm Xavier.
We're really excited to have you on the podcast.
Yeah, I'm excited to be here. Thanks for inviting me on.
So we're just going to go right into the questions, okay?
Sure, sounds great.
Okay, so we know you are in France right now. So what time is it there? It's only 10 a.m. for us right now, so what time is it for you?
It's about 4 in the afternoon.
Wow.
So 6 hours ahead of where you are.
So how about let's start with your job. Okay, so you're an astrophysicist. How would you explain your jobs to kids our age, and how much did you have to go to school to get your job?
Right, so I'm an astronomer or astrophysicist. They mean the same thing. A long time ago, 100 years ago, an astrophysicist was someone who did a bunch of math to try to explain things, whereas an astronomer was someone who looked at the stars through telescopes. And these days, everyone those two jobs are sort of mixed up. And so there's no real difference between the two. So what that means, what an astronomer does is, study stuff in space, which could be stuff that's close to the Earth, like asteroids or even dust in the upper part of Earth's atmosphere, or other stars or other galaxies, or the whole history of the universe. So it goes from really close to Earth out to as big as you can get. And what I had to do in terms of studies to become an astronomer is, I went to college and I majored in math and physics. And then I went to grad school and I got a Ph.D. in astronomy. And that's kind of where I learned how to do research in astronomy, to ask questions and try to figure out new stuff. And so that's kind of a typical thing you have to do to become an astronomer.
So how long did you have to go to school? Like how many number of years?
So let's see, after the end of high school, so starting at the end of high school, I did in the American system, so I had 4 years of college, and then I did 5, or was it 6 years to get my PhD.
Wow.
So a total of 9 or 10 years. I don't even remember. It was a long time.
That is a long time, yeah.
But the truth is, by the time you're in graduate school and getting a PhD, you're already an astronomer, really. You're already learning to do the same thing.
So we know that you write poems in rhythms, in a rhythm way, similar to Dr. Seuss. What gives you the idea to make your science into poems?
Oh, that was just for fun. It really came from the fact that I have 2 kids who are not too different in age than you two. And when they were younger, I would read them Dr. Seuss books like all the time, like almost every night. And at the same time, I was doing astronomy research and learning new things. And since for my job, I don't actually teach. So I don't teach any classes. And I thought, I still want to kind of share what I'm learning with other people outside of astronomers. And so I started a blog where I kind of write about astronomy stuff. And one thing I started doing was, I think it's fun for my kids, and me anyway, to do Dr. Seuss-y like things, read Dr. Seuss poems. So why not try to explain some astronomy in that kind of poetry? And so That's how it came about.
And it must be much easier for kids to learn about astrophysics, like astronomy, and through poems, because it's hard to learn through all the scientific kind of language that scientists speak in.
That was my hope, to try to make it more accessible and to show kids that science isn't, even though it can be hard, it can also be a lot of fun. And what's really behind it is there's a key fun aspect to science, and I wanted to kind of bring that out.
So how hard is it to write science poetry? Because with like the scientific language and words, there's not a lot of words that kind of blend together well in the like non-science language, I'd say.
Oh, that's a good point. It's super hard. I love poems and stuff, and I don't think I'm a natural like poet where I can naturally come up with rhymes super easily. I spend tons of time trying to find the right rhymes and trying to get the meter so it's not too bad. It takes a lot of time. Yeah, but it's fun.
So do you have a favorite poem that you've made and like written?
Um, I don't have a single one that's my favorite. No, I usually my favorite one is the last one I did. So, yeah.
And so if you can, could you read it to us?
Oh, sure. You want me to read you a poem? Let me do that. Let me load it up real quick and I'll read it to you. So lately, I have some that are on my blog. And then I wrote this book, obviously, where all the poems are in the book. And so the book was a bunch of poems trying to explain astronomy kind of in a general way. And on my blog, I write poems that are kind of just about new things, whatever pops in my head. So I wrote a poem actually just a couple weeks ago. If you'd like, I can read it.
Yes, please. Yes,
Yeah,
please.
that'd be great.
Cool. So the idea behind it is we had a new discovery that was really cool, where we found about 100 planets that don't have stars. They're called free floating planets.
Wow.
And so the title of this poem is "A Flock of Free Floaters." So let me here we go. A flock of free floaters. So planets and stars, they're always together. The star is a bird, each planet's a feather. What happens, you ask, when a feather falls out, gets caught in the wind, drifts up and about? We've found countless planets that orbit their stars. Some planets are gaseous, some rocky like Mars. They're called exoplanets. They're really quite awesome, abundant, diverse, like flowers in blossom. A handful of planets have likewise been found without any star, completely unbound. Mysterious objects, these rogues out in space, so faint it's a challenge to see just a trace. Now here's something brand new. We made a big splash. A pile of free floaters just dropped with a crash. 100 new rogue planets. Yep, we just found them. They orbit among stars instead of around them. How do we find all these rogues, you might ask? It really was hard, a gargantuan task. Nuria did the real work. No, not me. The project a key piece of her Ph.D. We first had to find out where rogues would be bright. The youngest of planets can shine in the night. Each planet starts hot, then cools as it ages. It's brightest by far in the earliest stages. The best place to look is a star-forming cloud, where stars and their planets are shining out loud. A cloud upper Scorpius close to the sun. A few thousand stars. It's young. It's the one. The problem, it's huge. It's stretched far and wide. A patch on the sky, 30 full moons aside. The plan, gather pictures wherever we can. Combine them together to build up a scan. The project we built is called Cosmic Dance. It's based at the Uni of Bordeaux in France. A database, hundreds of terabytes. Upper SCO imaged on dozens of nights. With all of this data, we got the full count of Upper SCO's tally, the total amount. There's 3,500 objects in all, most of them stars, but some are too small. We found some brown dwarfs. They're smaller and dimmer. Their cores do some fusion, but only a glimmer. The faintest of objects we care about most. They've got to be planets, and without a host. 100 rogue planets, each off on its own. Where did they come from, and where are they going? There's two possibilities with implications. The difference relates to the object's formation.
Wow,
Maybe
that's
there's.
good. Oh yeah. Sorry.
It
Continue.
keeps going. Here, tell you what. I'll jump around to a part that's close to the end. To wrap this all up, we've sort of gone rogue. We hope that free floaters will now become vogue. There's still lots of mystery, lots to be learned. Let's see what comes next. Now, poem adjourned.
Wow, that's a really good one.
Wow.
So you mentioned a book at the beginning of your poem. So what is it called, and like what where would you find it?
So the book is called Black Holes, Stars, Earth, and Mars. And it came out about a year ago in, I think it was October 2020. And so it came out before that last poem. That last one's
Yeah,
not in there.
definitely not.
Um, but I wrote it, so I wrote it over the span of a few years, just here and there. And then during the COVID confinement, I figured if I was ever going to actually finish it, that's when I could do it. And so I kind of was finishing the poems, and they really needed some drawings. And so I asked my older son, Owen, who's he's 13. He's going to turn 14 in 3 days. So he's almost 14. And he did all the drawings for the book. And so
Wow.
we had poems and drawings, and then we thought, it'd be cool to have someone famous kind of write a little introduction,
Oh,
and
cool.
ideally an introduction that's like in rhyme. And I've met Neil deGrasse Tyson before, and I asked if he would be willing to do it, and he was. So he wrote the introduction. He wrote a little poem. It's pretty cool.
That's
Uh,
really cool.
That's really
How
cool.
did
That's
you meet
awesome.
Neil deGrasse Tyson?
I met him at the Museum of Natural History in New York. So I know some people who work there, who work on study planets and how they form and stars and stuff, similar stuff to what I study. And I've gone to visit them before, especially because my wife Marissa, she grew up in New York City, not too far away from the museum, and so we'd been there many times. And so I went to visit these people that I knew at the museum, and Neil was there, and so I met him too.
So we've been to the museum. It's really nice. Like,
It's a really
yeah.
cool place.
Yeah, it's pretty amazing, huh? That giant iron meteorite that's hanging out there.
It's so big and there's so much to learn. There's so much information. Yeah. Yeah, it's a lot. So what made you want to be an astrophysicist?
Well, I mean, when I was a kid, I loved certain kinds of movies like Star Wars and, spacey movies. That still, even though I loved those, I didn't expect to become an astronomer. I didn't realize that that was something you could really do. I guess I knew it existed, but I didn't expect to be able to do that. I enjoyed figuring stuff out. I loved math, and I did like these kind of stories, like space type stories. And when I was in college, I went to a small college, and there was only one astronomy class, and I took it, and it was about like actually figuring out stuff in space, and I loved it, and I was able to get more into astronomy from there. So I'm not one of the people who decided I was going to be an astronomer from a very young age, but I was always interested in those things, and luckily they came together.
Wow. So I read your website and you also said you like make scientific backgrounds, not backgrounds for like sci-fi stories. So so I've read Ender's Game and it's like future in space. So have you read books and like with the scientific background and how did they get a realistic background?
That's a good question. So yeah, some of the funnest stories are out there. They're set off in the future, or they're set kind of right beyond the edge of what we already know now. And so the trick is, for certain types of books anyway, they wanted to make it realistic. And so it's possible to everything they say is plausible, even though we don't really know that yet. And so it's fun to think about that kind of thing. It's great. So the kind of thing I do often is the research I do involves planets on their orbits. What kind of orbits are stable around a star? How close can planets orbit each other before the gravity of each planet kind of pulls in the wrong way and makes the whole thing blow up? And so the kind of thing I've done is build systems of planets with lots of planets, more than you might expect, orbiting the same star, and shown that that can be stable, even though it's not necessarily what our solar system looks like. And among stars around other planets, we don't know of any that are quite as complicated as what I write about on my blog, but you can imagine it. And it's kind of like that. It's just beyond the limits that we know, and it fits with what we know about gravity, which is kind of cool.
So I love Star Wars too. Do you have a favorite movie?
Ooh, this was an easy question in the past. I mean,
I know.
obviously, The Empire Strikes Back was always my favorite, but these days I love some of the new ones. Rogue One was so good. Maybe Rogue One. I don't know,
Oh
but
really?
I really love them all, and my kids and I go to see them in the movie theater every time there's a new one.
Are you excited for the book of Boba Fett to come out?
Yes, isn't it today that it comes out?
Yeah, I'm pretty sure it is.
Yeah, yeah. Me and my older son Owen, we have a plan to watch it. So, yeah. Are you guys excited about that
Yeah.
too?
Did you watch The
Yes.
Mandalorian as well? When was that?
Yeah, those were so good.
They
I
were
love the
really
Mandalorian.
good. Yeah.
So on your website, you have a list of questions that you researched, and we were curious about a couple of them. One of them is where does Earth get its water from? Have you found an answer?
So, yes and no. So we have lots of different ideas. So the trick is, you might wonder, well, of course, Earth's the blue planet. We just have water. We always had water. That's how it is. And then when you kind of zoom out in time and imagine how planets come together and how they are actually built, it's not as obvious as you might think that Earth should have any water at all. So you might think, well, from space, we all know Earth is what, 3/4 water? It's about 3/4 oceans and 1/4 continents, something like that, if I remember right.
Mm-hmm. Yeah.
But if you look at the whole planet Earth, almost all of our water is on the surface. And so the whole planet put together, Earth is about 1 part in 1,000 water, right? It's 99.9% totally dry.
Oh, because everyone thinks of the surface, not of like the core and everything like that.
Exactly. And so you can imagine, how do you mix things in? It would be like, what's a way to explain it? It's like, just the kind of tiny little bit right on the surface. It's like the frosting on the cake. And it's like, well, why do you have that? And so we think that in the end, Earth did get water from somewhere further away from the sun where it was much colder. And so Earth was made out of rocks, but some ice that came from further out ended up bashing into Earth while it was growing. And that's why we have some water, but not a ton. Because there's some planets a little further from the sun, instead of having 1 part in 1,000 water, they have 1 part in 10 water, or they're half water. And so Earth is not that. If we were half water, then the oceans would be thousands of miles deep, which is not the case.
Oh, yeah. So also because with the gas giants that are way farther out, they have like rock and mist and all the perspiration, like that, it makes them very watery.
Yeah. Jupiter and Saturn are basically big balls of gas rather than kind of solid planets like Earth. Yeah.
Okay, so how do you continue to learn?
How do I continue to learn? So, so the simple answer is you just keep asking questions. And so why would you do such a thing, right? Aren't we done asking questions yet? And so I think this kind of thing is very natural for kids and less natural for adults. So kids, such as yourselves, I imagine you get curious and you're like, I wonder about that thing. Let's go check it out. I wonder about this or that. And adults are more, they've figured out what they wanted to figure out in life and are more set in their ways on average, right? Not every adult and not in every situation. But basically, so the key to like trying to learn new stuff is to keep that spark that kids have naturally. You keep it a lot. You try to keep it going. And so try to say, well, I'm really interested in this, so let's try to figure out more about that. So personally, in the way I do research, is that on purpose, I leave a chunk of my time open to whatever new ideas come along. And so I don't get stuck in the past. 6 months ago, I thought this one idea was great, and I have to keep doing it no matter what.
Mm-hmm.
So I do that to some degree, but I always leave some of my brain open in case there's some new discovery or some new thought, or someone, including kids, come and say, well, what about this problem? On that note, we did one study a few years ago about moons around other moons. And the idea for it came from my friend's son, who was 4 years old at the time. So.
That's the thing, because if you're interested in a lot of things, then you'll like know a lot of everything in a lot of different areas, and you'll be well rounded. So that's always good. So we looked on your website, and you were like talking about a lot of things, and I didn't get a time to look at it, but you had a section that said, how do planets die? So how do planets die?
So this is a fun thing that I thought of, that there's a lot of stuff out there on how planets are born and less about how they die. And so what I did in that series of kind of thought experiments was just looking at, based on what we know about how planets evolve, what can happen. And so the most common thing, what's going to happen to Earth, right? Our Earth has been habitable. We've had the conditions for at least liquid water for 4 billion years, but that's not going to last forever. within a couple billion years, the sun's going to get a little bit brighter and Earth's going to get too hot. And so we won't be able to have oceans anymore. Right? That's kind of one way that planets die, just their stars get a little hotter, they evolve in time. Right? And so it's not going to happen tomorrow, but it'll happen in, people aren't exactly sure when, something like a couple billion years from now. There's also more dramatic ways that planets can die, like if a system of orbits. So imagine this planetary system becomes unstable. Imagine Jupiter's orbit went unstable because of Saturn, for example. Now that's not going to happen to us, but it could have happened in the early solar system if things had been a little different. So if Jupiter's orbit went a little bit unstable, Jupiter is more than 300 times more massive than Earth. It would kick Earth all over the place. It might send Earth into the sun. That's another a way for planets to die.
So, is it actually true that moons can have their own moons?
Yeah, good question. So this is the question that my friend's Juna, her son, had asked her that question, and then she came and talked to me, and we tried to figure it out. And so the answer is we think so. We have yet to find one, but we tried to map out kind of where in the possible configurations of moons around moons one could fit and stay stable. And we think that they should be able to exist in certain places. And they have not been found yet. So maybe there's some other complications that we haven't figured out. Or maybe they are out there and we're just waiting to find them. And the conditions are not quite right for any of the solar system's moons. So we got to wait till we find moons around other stars and then try to find moons around those moons. So we think it might be possible. And then now we got to test those ideas. It's a fun, so you'll find in science, it's a fun thing where you kind of ask a question, come up with an answer, and then you say, does that answer really work? Then you get to go test it out and come back again. And sometimes it turns out you got it right, and sometimes you messed up.
So, what's your favorite planet and why?
So it is Earth. When I was your age, my favorite planet was Neptune because I love the color.
Me too. I like
Yeah.
Neptune. I don't know. It's very
Totally,
fascinating.
totally. I love Neptune. I still love Neptune. Now I appreciate, now that I've studied a lot of other planets, or I love Earth best just because, we're the one planet where we know that we have, life, which is pretty cool.
Yeah. So lots of people who aren't astronauts are going to space right now. So would you like to go to space and why?
I never had any grand ambitions to go to space. I think that it would be pretty cool to go and just, do the kind of thing where you go up into suborbital flight and look down on the Earth and say hello and get to see the universe from a different point of view. I think that would be amazing. So I would be up for doing that. That'd be pretty cool. I have no great aspirations to go to the moon or Mars or anything, but to go on one of those suborbital flights, I think it'd be good fun. How about you? Do you two have interest in that?
Well, it's kind of really dangerous.
I've researched a lot about going up into space. Everyone's like, "Oh wait, I want to go into space. It's so fun." But the thing is that the astronauts train for 4 or 5 years. They get used to it. They get the launching. But people who just go up, they don't have any training, so it's very dangerous for them to go.
I would love to go to space if it wasn't so dangerous. I mean, I guess the launching part isn't that dangerous. The kind of landing back down to Earth is the most dangerous part. But I kind of want to feel the anti-gravity and do the space station for however long, 6 months I think is what they normally go by. Yeah. And I also did a project on they're starting to do more innovations in space, growing plants in space, and I find it really interesting, and I want to probably just experience that hands-on. So I think that'd be fun.
That's cool. Yeah, I don't know if you ever heard of there's a certain type of plane that I forget what they're called. I know the kind of the colloquial name. Where they go on these special trajectories so you can get 0G.
Wow.
So you can be in basically have no gravity. What it does is basically the planes, you can have zero gravity if you go up in a plane and the plane just drops, right? Because you're in free fall. But you don't want that. You don't want to actually, but the plane can basically do that kind of trajectory where you're in free fall for about 20 seconds at a time. And I know the name that they refer to these planes as is they call it the Vomit Comet because a large fraction of people get sick.
That would make sense. That would make sense. So away from science, you were pretty good at ultimate frisbee. Tell us about being on a European team and winning a championship.
Well, that was super fun. So I've played ultimate frisbee for a long time since I was in college, and then I've been playing it since we moved to France. And I got the chance to try out, and then I made the French national team. And even though I'm not a French citizen, they're allowed to have one or two non-citizens on the team, which is lucky. And so I got to go play in some of these cool places, in these international tournaments. I got to go to the World Championships in Japan. I got to play in the European Championships a few times, and the last time I did it was in 2019, and we won the European Championship, at least in my age bracket in Spain. It was really cool. It was super fun to be able to
That's
do.
cool. What was the nicest spot you went to?
Oh, during doing ultimate stuff?
Yes.
Uh, I think it must have had to be Japan. It was outside of Osaka, a town called Sakai in Japan. It was really, really fun experience. Yeah.
So when was the time you failed at something or it didn't go the way you planned, and what did you learn from it?
Hmm. Let me think. I mean, I don't have a great one on the top of my head. The truth is that I fail at things like all the time. So, so I kind of get used to it. So now I expect it. I remember when I was, well, here's one example. During my PhD thesis, I was working on this code to do this kind of simulation code that was going to do what people had been doing before, but better and faster and with new little things that were going to work better. And it never worked. And so I failed at making this code work. It was really frustrating. I worked on it for like 2 years. And I always had this weird little bug in my code, and I never quite trusted. And so, but what I learned out of that is at the same time, I wanted to compare what I was doing with what everyone else was doing before. So I ran a comparison simulation beforehand of how the planets could form. And that simulation ended up being really useful. I used it for years because it was better than anyone had ever done before, just because I knew it was going to take me so long. And so I did it in a complicated way. And so I don't know. I guess I got used to expecting to mess up the first 5 or 10 times, which was very useful.
So who or what inspires you?
I guess I'm inspired by people who aren't, who try new things and who are, bravely try new things, understanding and accepting that they might not work and just giving it a shot anyway because they believe in it and they want to give it a shot. I also, on that same note, I really am inspired by people who, doing that doesn't have to be like building some grand, gigantic thing. It can be, doing something and including people who are not used to being included, who've had, less opportunities, or doing things a new way that's more environmentally friendly. Or there's a million different ways that this can be applied, but just going for it and giving it a shot. I'm really inspired by people who do that.
Wow.
So before we end, is there anything you would like to ask us?
I am impressed. So I kind of want to ask you the question that you asked me earlier is what keeps you curious and asking questions of people?
A lot of things. I just seem sometimes when I'm in school and we talk about a new topic, I'm not actually like interested in that one topic. There's always the branches in that like the small topic. So if they mention one thing once, like we were doing space phenomena as one of our last units, and everyone was like, there was this thing called spaghettification. Yeah, so we never really learned what that was, but the thing is that I was pretty interested in that, but also all the other phenomena. So I ended up doing the Helix Nebula, and I just like learning about things, which like a big branch of something, the subtopics in that big branch, no matter kind of what it is, as long as I'm interested in the topic.
So
That's cool. Oh, sorry. I want to hear your answer to Xavier. Just to reply to Emma really quickly. I One of the poems that I wrote in this book includes a part about spaghettification, about things falling into black holes and getting spaghettified. And Owen even did a drawing of spaghettification. So
That's
I'll send
awesome.
you guys a copy of the book and you can check it out and see if you like it.
Thank you. That would be
Yeah,
amazing.
thank you. That'd be great.
So what usually keeps me curious is if there's a topic that we're doing in school or something, and then I find something that is interesting to me, I don't want to stop learning about that thing until it's done, and that's just, it just keeps me so curious.
Cool. That's great. I mean, I think it's, like I was saying before, I think it's super, really natural for kids to be curious about things. And it's really important as adults to keep that going. So I really appreciate your podcast
Thank
that you
you.
focus on the curious stuff.
Well, thank you for joining us. It was really fun.
Thank you so much.
Well, thank you for having me. It was nice talking with you.
It was fun talking to you too.
I forgot to ask you, what's your favorite thing about space?
Oh, the unknown about it. There's so much to learn.
Yeah, everything we don't know about it, it's just awesome.
You're not going to run out of things to learn in space. Keeps going forever.
Yeah. So Happy New Year. Have a great day.
Same to you. Happy New Year. Nice talking with you and happy holidays.
Bye.
Bye. That was an amazing interview. I couldn't believe that there's a theory that moons can have their own moons.
I liked hearing about his scientific theories. I liked how he converted facts and theories about the universe into a poem book.
We can't wait to read Sean's book. It is called Black Holes, Stars, Earth, and Mars, Astronomy Poems for All Ages. You should go check it out, and you can go buy it on Amazon. We will post a link to Sean's website if you want to learn more about his book or all of the cool topics he is researching.
Thank you for listening, and I know all the shows you listen to probably say this, but please rate the podcast and download the episode. And follow us on Twitter and Instagram. That'll be in the show notes. And if you want to say hi to us, we'd love to connect with you.
Thank you so much for listening to this episode of Curious Conversations.
Bye!